Hello. Great to see that you're working on math. Hope you're having such a nice day. Here we are with another geometry lesson for you. So, this is circles, continuing that unit, talking about arc and angle measures. So, we have a few practice problems to do together, and then you have a worksheet for homework. So, I'll go through and read some of this. We'll do some practice problems, have some that I'll let you try, that I'll give you the answer for. Here we go. So, there are different intersections that we're going to talk about. The first one being interior intersections. So, as we look over here, if two secants or chords intersect inside a circle, so that's interior, then the measure of the angle formed is equal to half the sum of the measures of the intercepted arcs. So that's what we see. That's what we see over here. So the measure of angle 1 is half the sum of the measure of arc AD plus the measure of arc BC. Whereas the measure of angle 2 is going to be half the sum of the measure of arc AB plus the measure of arc CD. So let's do a few practice problems that apply that property. So right now we're looking for the measure of of angle STR. So that's this angle right here. So that is going to be equal to half the sum of its intercepting arc. So 112 plus 186. So you can put that right into your calculator, and then you get 149 degrees. Number 2, we're looking for the measure of angle YWX. YWX, that's right here. So we notice that we don't have measures of those intercepting arcs. We don't know what the measure of YX, arc YX and arc VZ are. But what we can do is find the measure of angle YWV by using these intercepting arcs. So that'll be half of 43 plus 81, which is 62 degrees. So right here, that would be 62 degrees. But we're looking again for angle YWX. So we have to do 180 minus 62 because they're a linear pair. And that gives me 118 degrees. All right, now I'm looking for the measure of arc LK. So that's this arc right here. I see that I have that interior angle from the intersection of the two chords, and then I have the other intercepting arc measure. So now I know that 62 is going to be half of the sum of those two arcs. So that'll be 74 and x. Rather than distributing the 1/2 to both terms, I'm just going to multiply the 2 to the other side. So I'm going to have 124 equals 74 plus x. So I just multiplied that 2 to the other side, inverse operations. Subtract 74 on both sides, and then I get x equals 50 degrees. Okay. This one you should be able to try on your own, and you should get the measure of arc QT to equal 107 degrees. All right. So that was interior intersections. Now we have intersections that occur on the circle. So if a secant, that's AB, I can make this more clear to make crop well. So if a secant and a tangent intersect at the point of tangency, which would be point A, then the measure of each angle formed is equal to half the measure of its intercepted arc. Therefore, the measure of angle 1 is going to be half the measure of arc AB. The measure of angle 2 is half the measure of arc ACB. Okay. So let's try number 7. We're looking for the measure of angle DEG. So that's this angle right here. And I see the intercepted arc is 308 degrees. So I just take half of 308, which gives me 154. So that's 154 degrees. Now here I'm looking for the measure of angle DBC. So look here. I don't have the measure of that intercepting arc, but I do have the arc over here, 192. So I just do 360 minus 192 to get 168. So that's the measure of the intercepting arc over here. And then half of 168 is 84. So the measure of angle DBC is 84 degrees. All right, and then another one for you to try, measure of arc XY. You should get 58 degrees for that one. Two different ways that you could do that one as well. All right, so we did interior intersections on the circle intersections, and now we have exterior intersections. So if we have secants and or tangents, see the options here. If they intersect on the exterior of a circle, then the measure of the angle formed is equal to half the difference, so we're subtracting now, of the intercepted arcs. So it's the same thing. You're going to do the regardless. So you're doing half of the bigger arc minus the smaller arc, or the farther arc minus the closer arc. And that's true with all of these. Okay, let's try number 10, see if we can identify that one. So we're looking for the measure of angle KLM. So that's this angle right here. That is going to be half of the further arc, 140, minus the closer arc, 66. Do that right in my calculator, and I get 37 degrees. I'll make that look like a 37. Okay, now we're looking for the measure of angle PQR. So when we look at this at first, it doesn't look like we have enough information because we just have the measure of arc PSR, but we can get the measure of arc PR, because that's going to be 360 minus 313, which gives us 47 degrees. So then when we find the angle measure, that's going to be half of 313 minus 47. Half of 313 minus 47 is 133 degrees. Okay, moving right along. Measure of arc SW. So now we're looking for the arc measure. We don't have that. And because we're subtracting, order does matter. So I'm going to set this up the same way. The angle, which in this case is 40, will equal 1/2 of that bigger arc. We don't know, so we'll call that X, minus the smaller arc, which we do know is 75. Again, rather than distributing my half, I'm going to multiply by 2. So now I have 80 equals X minus 75. Add 75 to both sides to solve for x, and I get x equals 155, 155-degree arc. Okay, this one, similar idea, we just don't know that closer arc. So 56 is equal to half of 160. That all looks so ugly, I'm sorry, the stylus is not the best. 56 equals half of 160 minus x, because that's the one that we don't know. So I'm doubling. 112 equals 160 minus x. X equals 48 degrees. All right, 14 looks very similar to number 12. You should be able to try that one and get 116 degrees. And then 15 is a little trickier just because of the question that they're asking. We're looking for the measure of arc EF. EF. So we'll have to do an extra step at the end to find that, because first we have to find the measure of arc FH. So the measure of angle FGH is 77, which is half of 191 minus x. So we'll multiply by 2 to get rid of that half. 154. Set that equal to 191 sorry, got distracted. 191 minus x. And here I got x equals 37. But remember, that's not my final, oh my goodness. That's not my final answer. That's the measure of this arc right here, 37 degrees. The measure of arc EF is going to be the whole circle minus 191 plus 37, which will give me 132 degrees. All right, then we just have a couple problems that involve algebra. Maybe you'll think this is easier, maybe you'll think this is trickier. Still the same concept. With the intersection, we need to determine whether they're interior on the circle or exterior first, so we can set up the problem appropriately. So here we go. The directions state to find each value or measure and assume that segments that appear to be tangent are tangent. All right, so number 16, looks like we have an intersection in the circle. So I know that I'm going to use that first formula where the angle 3x plus 23, again, I apologize for the handwriting, is half of the sum of the two arcs. So that's 55 plus 75. So that's my initial setup. Then I have 3x plus 23 equals, plug that in, 65. And now I just have a two-step equation that I need to solve. I get 3x equals 42, x equals 14. I circle back and see that I just need to solve for the value of x. That's what I did. Boom, we're good. Number 17, solve for x. So this is an intersection on the circle. So I know that the angle measure, that's the expression for the angle in this case, 6x minus 38 is half of the arc measure. And because I can just evaluate half of 140, like I could evaluate half of the sum of 55 and 75, I'm not going to multiply the 2 to the other side because I can just simplify that in one step. So I have 6x minus 38 equals 70. Two-step equation, 6x equals 108. Divide both sides by x. Nope, divide both sides by 6 to get x. X equals 18, and we're looking to solve for x. All right, 18 was the answer to the last question. Now we're on number 18. How cool is that? All right, so now we have an exterior intersection. So this would be out. So 7x minus 1 equals half of the bigger arc, 161, minus the smaller arc, 65. So we do all of that to get 48. So 7x minus 1 equals 48. 7x equals 49. And solve for x. So once I get there, I'm done. X equals 7. All right, and 19 looks like it has another extra step there. We need to find the measure of this arc right here, because this is an exterior intersection. So I do 360 minus 74 plus 86 to get 200. So this arc right here is 200 degrees. So the measure of the angle, 4x plus 13, is half of 200 minus 86. So 4x plus 13 equals 57. 4x equals 44. So x equals 11. Fun stuff. Yeah, maybe not. I mean, I'm having fun. All right, and then if you where the circle isn't labeled, but you're given that verbally. So, and this is also different because we're looking for the measure of the angle in this one rather than just stopping at the value of x. So let's power through. The measure of arc JM, I'll just label that, is 10x plus 9. The measure of arc NL is 28x plus 17, and the measure of angle NKL is 16x plus 19. Find the measure of angle NKL. All right, so this is intersection N, and we have both of the intercepting arcs here with this angle right there. So I know that the measure, I know that the measure of the angle is half of the sum of the two intercepting arcs. In this case, it doesn't really matter whether you distribute the half or multiply to the other side. I'll multiply to the other side just because that way I don't have to worry about decimals in the event that we would get one. So I have 32x plus 38 equals, I'll combine like terms there, 38x plus 26. That leaves me with 12 equals 6x. So 2 equals x, which is not what I got when I did it. So let me just check my answer real quick. 2 here, 32, 19. Oh, good for me. Okay. So now I have to substitute that into the measure of angle NKL, which is 16 times 2 plus 19, which will give us 41 degrees. The average temperature lately, am I right? Okay. All right, that was number 20. 3 more to go. 3 more to go. It's totally fine. The measure of angle TSV equals 6x plus 17. And the measure of arc SV equals 15x plus 13. Find the measure of arc SUV. All right, so let's see what we have. We have this angle. We have this arc. Great, we know there's a relationship there for on. We want to find SUV. I'm going to find that arc. So I know I'm going to have to do 360 minus something at the answer. Okay. So the measure of the angle is half the measure of its intercepting arc. So I'll multiply by 2 to both sides. 12x plus 34 equals 15x plus 13. So I get 21 equals 3x. With x equals 7. So I have to find the measure of arc SV first. So that'll be 15 times 7 plus 13. Of course, I didn't do it, so I did it another way. 15 times 7 plus 13 is 118 degrees. And then I know the measure of arc SUV, major arc, is going to be 360 minus 118, which will be 242 degrees. Okay. Next one, this is an outside intersection. Let's see what we're given. If the measure of arc NJ, wow, best arc, is 170 degrees, nice. The measure of arc MK is 5x plus 8 degrees, and the measure of angle MLK is 4x plus 3 degrees. Find the measure of MLK. So you just have to plug that in at the end. Great. So the angle measure is half the difference of the big arc, 170, minus the smaller arc. I'm going to put that in parentheses because we have to make sure that we're distributing the subtraction. Multiply both sides by 2. 8x plus 6 equals 170 minus 5x. There was a plus 8 here. I'm sorry. I'm so sorry. And then it becomes minus 8. All right, get all my variables to one side, which leaves me with 13x. All my constants to the other side, leaves me with 156. So x equals 12. And then I'm looking for the measure of angle MLK, which is, substitute in, 4 times 12 plus 3, 51 degrees. All right, last one. Sorry, the fun's coming to an end. If the measure of arc QTS equals 16x plus 23 degrees, the measure of arc QS equals 7x plus 15 degrees, and the measure of angle QRS equals 5x minus 3 degrees, finds the measure of arc QTS. All right. So the angle, 5x plus 3, is half of the difference of the bigger arc in this case, 16x plus 23, minus the smaller arc, 7x plus 15. All right, so I put that in parentheses and then a bracket because there are multiple grouping terms. So now I'll multiply both sides by 2. So I have 10x plus 6 equals 16 minus 7 is 9. 9x. 23 minus 15 is 8, positive 8. All right, and then I'm left with x equals, oh my gosh, I keep messing up my signs. That's a 5x minus 3, 10x minus 6. So then I add 6 to both sides, gives me x equals 14. And I'm looking for the measure of arc QTS. So that'll be 16 times 14 plus 23, which is 247 degrees. Okay. I hope that this is a helpful resource for you. I know it was a little bit long, but some of the problems were lengthy. And reach out if you need anything. Have a good day. Bye.